Hey everybody, Mr. Troy here. I promised earlier to make a video about representing complex numbers on a plane, so I just wanted to take some time and do that. So think way back to elementary school. You might have learned that 2 is on the number line right here, and that if you wanted to do 2 minus 4 or 2 plus negative 4, you would start at 2 and then go 1, 2, 3, 4, and see where you ended up. Right? That's something that we're kind of familiar with. That this is 2, moving backwards is the act of subtracting 4, and negative 2 is where you end up. Nothing new there. So complex numbers can be represented in the same way, but they're not graphed on a number line, they're graphed on a plane. You need 2 dimensions, one for the real part and one for the imaginary part. So this is the regular real number line, from negative infinity to positive infinity. And then this is the imaginary axis. So if I wanted to graph the number 3 plus 4i, I would go to 3 on the real number line and 4 on the imaginary number line. And I can either represent that using just the point, or sometimes I'll represent it using a vector. Now the reason that people use a vector is because it helps us see the angle at which that happens, which eventually is going to be useful to us. And it allows us to see the magnitude of the number. More on that in just a second. So when you talk about the magnitude of a real number, that's called the absolute value. It's how far is that number from 0. For both positive 3 and negative 3, those are 3 units from 0, so they both have an absolute value of 3. Now, if instead I ask you what numbers are 3 units away from 0 on the complex plane, well, you would still say 3 and negative 3. Those still work. But wouldn't 3i also be 3 units away? And by the same token, wouldn't negative 3i? In fact, there are an infinite number of things that are 3 units away from the origin. Really anything that falls on that circle. Once you know all of this, you can begin to see how easily this ties into a bunch of stuff that you already know or you've already seen, or that kind of hints at things that maybe you kind of know, things at the edge of your knowledge. So now that I say that, if I ask you, what is the absolute value of 3 plus 4i? You can put that together in just a few steps. Well, that means how far is it from 0? The next thing we ask ourselves is, well then, how long is that segment? If I'm thinking about this as a vector, what is the magnitude of this segment that I can see there? And then I think suddenly you realize that this is just a geometry problem. And I'm sure you could figure out how to find that this is 5 units long. Now, here's some verification that it is indeed 5 units long. Note where that circle with radius hits the x-axis, the y-axis, the negative x-axis, the negative y-axis, all at 5s, comma, correct? So if I want to add two complex numbers graphically, I could take this same idea. So if I take 2 plus 3i, let's go ahead and plot that. Remember with the number line, when I wanted to add or subtract real numbers, I would start at that position and then move forward or backwards. So if I want to add, say, 3 plus 2i, I would instead start from this position and displace by 3 units towards the real and 2 units towards the imaginary. So that's where I would end up. And then my total sum would be that point's displacement from the origin. In this case, that would be 5 plus 5i. Now this doesn't tell us anything that we didn't already know, but what it does tell us is a reason for this to work, which is something that we didn't necessarily have before. Now we have a reason why we add this way. All right, thanks for watching. I hope you found that enjoyable. I know it's not strictly necessary for us to learn that, but I just think that the complex numbers are neat. All right, see ya.